Good morning, or good afternoon, or good evening, I guess. You could be watching this at any time. This is section 4.6. We're going to sketch our polynomial functions. I will be teaching you two ways today in this video. The first way is right here. Second way is right here. Please pick whichever one works best for you. I do not have a preference. So the first way is we're going to look at this function. Notice that there's a power 1, 1, and 1. This is all being multiplied. So if you took a power of 1 times a power of 1 times a power of 1, you'll see it's actually going to be a power 3. So this is power 3, or degree 3. So it is an odd function. And reviewing from our video before, an odd function has that like Travolta look, where it starts and ends in different directions. Okay, so that's the idea. Now we're going to have two ways to graph it. First way is looking at the x-intercepts. X-intercepts means y is 0. So if I plug in 0 for here and solve, I get a nice zero product property. That means x could be 0, -1, or 3. Then if I find the y-intercept, x is 0. So when you plug in 0 here, here, and here, you'll actually find out that x and y will be 0. Okay. Now that we have our intercepts, we're going to talk about intervals with our x-intercepts. So I'm going to put my x-intercepts down here. And now I'm going to test in these intervals if the function is positive or negative. Now this should look familiar when we talked about our rational inequalities, where we tested if the interval was true or false. Well, now we're testing, is the interval during this portion going to be positive or negative? So for example, if I plug in, let's say I plug in 1, because that's between 0 and 3. So I'm going to go into the function, plug in 1. I see I get 1 times 2 times -2, so I get -4. So in between the intervals 0 and 3, this is going to be negative. Do that for the remaining. You should get negative, positive, and this one should be positive as well. Okay, that's going to tell you where the function should be. I'm going to graph my x-intercepts, 0, -1, and 3. Don't know what that little dot is. And now I can create these similar intervals. So I'm going to maybe do a little dashed line. Again, a lot of this will have to be erased in the end, but it will help get the shape. And now we look. Between -infinity to -1, the function should be negative, which means it will not be up here. This is positive. So all the way up to -1, the function should be below the x-axis. Between -1 and 0, the function should be positive. That means it's not going to be down here. 0 to 3, it should be negative, so I can cross out up here. The function's not going to be here, as well as it will not be here. Okay. Now I need to look for some key points. That would be helpful. What if I plugged in something to the left? So what if I plug in like -3? Okay, go back to my original function. -3 times -3 plus 1 times -3 minus 3. That will give me -36. So yeah, somewhere down here, right? So I know it's going to look like this. This will be my start. It's going to be some point down here. What if I try to plug in some other point, like 1? If I plug in 1, I get -4. So there's 1, 1, 2, 3, 4. Okay. If I plug in 2, I'm just trying to see a shape. I would get -6. Well, a little off the graph, but that's okay right now. We're just getting the shape. And maybe, what about like 4? 4, I would get 20. Okay, so really off. Up here. Okay. Now, the whole reason why I do this is because I want to make sure my intervals are correct. It is an odd function, which means it's going to go to the bottom and to the top, right? It's an odd function, different shape. And now when it goes through these intervals, it's going to go like so. Well, kind of sketchy, right? But it goes up, goes down, and goes back up. It's an odd function. There's at most these 2 turning points. So I'm good to go. This is one way to graph it, using your intervals positive and negative. Another way, again, it's going to be the same problem. So we actually will have the same x-intercepts. It's going to be -1, 0, 3. The y-intercept is 0, 0. And now what I'm going to do is look at the function at each x-intercept. So here's the function again, just so that we have it. It's x plus 1, x minus 3, just like above. I'm going to look at it at each of those intercepts, which means I'm going to look at these imaginary exponents, these 1s, and think about the shape. Put this down here, I'm going to zoom out a little bit. So at -1, so this intercept right here, the power is 1. If I think back to that power function, when x raised to a power 1, that's a nice straight line. Let's look at the intercept when x is 0. Again, it's a power 1. That should be a straight line. At x equals 3, power 1, straight line. Okay, that's the power functions. Think back to yesterday's notes. Think about the power function. What will the general shape look like? This will look like that straight line. So now I graph my intercepts. -1, 0, 3. I know it's an odd function, right, because the powers add up to 3. I know it's even because there's a positive value in front. There's no negative sign. So I already know, since it's even, it's going to look like this and this. That's going to be the start. Okay, I know it's going to be like that. Now I'm going to look at each individual x-intercept. At the intercept -1, I'm going to go through it. Kind of see this straight line idea. Well, if it's going up and at 0 it also needs to be a line, well, that means it has to come back down and get a nice straight line through here. Okay, I'm looking at the general shape at the intercept. If I look at the intercept of 3, it needs to be a straight line. So here I need to have this straight line. I know it's going up because it's that odd function, which means that somewhere around the line we'll have to curve and come back up. Okay, so that's 2 ways to think of it. Again, it's a sketch, so don't worry about putting exact points, but it's really important about the shape at the x-intercept and the ending behavior. Let's try a couple more. Example 7, determining the shape of a graph of a polynomial function near the x-intercepts. Really, this is honing in on the second way. Okay, so here's the first problem. F of x equals 1/2 x minus 3, x minus 1 cubed. Okay, let's identify some information. This is really a power of 1 right there. So since this is all being multiplied, we need to notice when you multiply like bases, you add your exponents. So this is really degree 4. It's an even power. It's even and the coefficient in front is positive. So this will be the direction. It's going to both open up because it's even and it's positive. Let's look at our x-intercepts, and we're going to talk about what they should look like. The first x-intercept is when you set y equals 0, so 0 product property. You will get 3 and you'll get positive 1. At 3, the power is 1, which is a straight line, so it's going to go right through it. At the exponent, at the intercept of 1, it's a cubed power. So that's going to have a little bit of a curve action to follow that power function. So let's take a look. If we graph it, we have 3 and 1. Those are my x-intercepts. I know it's an even power and it's positive, so I know this will end up. This will end up. Now I have to look at the shape. At x is 3, it's going to be a line. It's going to look kind of like a straight line here. At positive 1, it's going to have that little curvy shape. So please, please, please try to make that curve shape alive and tell the difference between the x-intercept of 3 and 1. And we know it's going to come back up. Kind of looks a little weird, but that's what it's going to be so that it's an even function. Those are my exponents. Those are the behaviors at those x-intercepts. We saw those by the exponents. Okay, so it's a sketch. If you wanted it to go a little bigger, you could. It went a little lower. Again, this is going to be a sketch for this purpose. Let's look again at this next one. We'll look at those powers. When there's no power, there's always a 1 up there. So the degree will add up all our exponents because it's all being multiplied. So 2 plus 1 plus 1 is degree 4. It's even because the coefficient up here is positive. So it's going to look like this, right? Both open to the top. Let's look at our x-intercepts, which is a nice zero product property. You'll have an x-intercept at -1, at -4, and at -3. It's kind of very close together. At the x-intercept of -1, it's a power of 1. Power of 1. Now we get a power of 2. Okay, think back to the power function of 2. That's this, right? It's going to be like a little bounce. So when you get to the x-intercept of -3, it's not going to cross through. It's going to have that U shape with that vertex or min-max and bounce back in the direction it came from. Okay, that's because of that 2 as the exponent. Let's see what that looks like. So 1, 2, 3, 4. Here's -4, -3, -1. Okay, it is an even positive function, so I know this will be the ending behavior. Now I need to look at each specific x-intercept. At -4, it's going to go through. At -3, it's going to bounce. So what that means is it needs to come up and then it bounces back down. Okay, so it went through here, it bounces here, and then at -1 it's going to cross through. And that actually is the only way this graph will look right. If I didn't let it bounce, it will not have the correct ending behavior. So there's kind of multiple ways to check as you go. It has to have the correct ending behavior, and it needs to have the correct intercept behavior. But that would be a bounce because of that 2 even power. Okay, partner time, aka time for you to try your best. Please pause the video. Here we go, guys. So the hint was to factor. Hopefully you paused the video. All I meant by that is you want to get it in the most factored form. So you can take out a GCF right there of an x. Now this is in factored form, so we can find those intercepts much, much easier. Okay, we'll look at our powers first. When you add them all up, you get an even power. Man, oh man, did I pick same problems? So the degree is 4. It's positive in front, so again, this will be the ending behavior. Let's look at those x-intercepts. So at each one, you can use zero product property. X-intercept of 0, -2, 3. The y-intercept, if you plug x equal to 0, you should have got 0, 0. And now our turning points. We will actually use our calculator for this portion, so if you were trying to do it on your own, now you realize you can use a calculator. You should have be a little relieved about that. But let's figure out the shape of this graph. So at each x-intercept, looking at the degree, this would be a line at 0, a line at -2, and oops, it's going to bounce at 3 because of that even power. Let's take a look. So -2, 0, 3. It's an even positive function, so that's the ending direction. At -2, it's going to pass through. At 0, it's going to pass through. And at 3, it's, sorry about that, guys. Should not be really lined, it should be nice curvies. And then at 3, it's actually going to bounce, which is perfect. I needed it to bounce in order for it to end in a positive direction. So there's my shape. Hopefully you did good so far. Now, for the turning points. With our sketch, we can't really be exact. So that's why we're going to grab out those calculators and use our max-min function. You should feel very, very confident with your max-min functions by now, but we're going to find these turning points. So this point right here and this point right here, where they turn shape. Realize this is a degree 4. Oh, I'm sorry, and this is a turning point. This is degree 4, so you can have at most 3 turning points, like we have here. So use our calculator. We're going to go second trace. You're going to choose max or min, depending on which turning point you are finding. You will deal with your right-left bound, like we've been worrying about. If I can spell hello today. And let's see. You should try this on your own, and let's verify you get the same answers as me. I got -1.22, -16.95 as one turning point, +1.22, 12.45, and then we actually knew the last turning point here. Okay, so make sure you can do this on your own. Make sure that graphs make sense. You can check your work as you go, and good luck.